everyone, welcome to this next part of our video where we will be looking into the types of infrastructures available in cloud services, and we will also discuss about some network basic things. First of all, let's start with this service infrastructures. So basically, the cloud has different models of providing you services. Some models are some very widely used models that we have is like infrastructure as service, then we have platform as service, software as a service, and function as a service. So when we talk about infrastructure as service, then we have to take an example of how you want your service, your application to run on cloud. So whenever you have you know ability to create your own infrastructure, create your own environment, deploy your own on own platforms. If you have that ability, if you have that resource to invest time in doing all this, then you can obviously go with the infrastructure as service. So let's take an example of compute engine. So compute engine is like you have to set up a compute engine, then set up environment in the compute engine, set up your application, your networking, your all other different things, maybe scaling, auto scaling, balancing, health checks. There are multiple aspects of of running a successful service or successful application in cloud. So doing all those things by yourself, it's known as infrastructure as service. Like cloud is providing you infrastructure, you can use it and create your application or your architecture on that. So that's one model. The second model is platform as a service. Think of a scenario where you just want your code to run. You don't want to think about creating environment, deploying machines, doing all those scaling, auto scaling, or all those things. You don't want to deal with those things. So for that, this service, platform as a service, is very useful. Some of the examples we have is like app engine. So app engine is a very suitable candidate, and we can categorize it as a platform as service, because it's allow you to just give your code to the app engine and it will do its task. It will create your URLs, it will run your code, it provides ability to roll back, it provides ability to scale. So these are some basic things you can do with the platform as a service. You don't have to worry about the inlining infrastructure and other time taking things. Okay, now this software as a service is kind of very usual thing that you see, you come across in your daily life. You must have used Gmail, Google Docs. So these are softwares that can be accessed easily using your Chrome browser or any browsers. So these type of services are known as software as a service. Okay, so I will also put here an example of Looker. So Looker is also a software as a service. It allows you to utilize the other services as a UI, and you can plot graphs, diagrams. So it's about a software running in cloud, and you don't have to worry about any other things, not even the code. So that's what a correct example of software service. Function as a service is something I could say kind of platform as a service, but it's very straightforward, very a different way of doing the same thing. You must have came across cloud functions or Azure functions, and in AWS we have Lambda. So it is also something you don't worry about. You don't have to worry about your infrastructure, setting up the environment, servers. You don't have to worry about that. It's already been given to you. So you just have to upload your code, or maybe any Docker thing if you have. So you just have to upload that, and you are ready to go. So that's something is function as service. Okay. And as we talk about the infrastructure services, we have came across this term serverless. So I want to tell you, like, serverless is a term. It's not like there is no server. It means like you don't have to worry about how server is created, how it's deployed, how it will be, taken down, how any aspect of the server. You don't have to worry. You just have to put your code, and rest of the things will be taken care automatically. So that's how service infrastructures are designed, and multiple models are evolved till date. So now let's see some visual representations to describe how much effort is required to manage uh, a, a service type. So traditionally, when we are running everything on by our own, that we call as running services, your application on premise, it's all user managed. So you have to take care of all these lists that are in blue. So you have to create your own networking, then storage, then servers, maybe virtualization as well. You know, this something have to very critical. There is something there very critical, that is security. You also have to take care of the security as well, then database, and obviously the application. So all these things is been taken care by you, and it requires multiple human resources as well. And when we talk about infrastructure as service, then many of the aspect of of this on-premise are taken care by the cloud. So you don't have to worry about any of the networking things, storage, server hardwares. So and virtualizations, this you don't have to worry. You only have to worry about creating your application databases, and somehow little bit of security as well. So these are something that you need to take care when you are using infrastructure as service. And when we come across platform as service, it's really easy. Like you don't have to worry about anything. You just have to worry about your application and your database. And then we have already seen software as service. It's already there. You just have to log in and use it. So this is a visual representation that will give you a good idea, like how things are differentiated. So let's move ahead with our next topic, that is networking. So uh, when we talk about networking in cloud, before going and discussing the networking as a perspective of cloud, let's take an example of your office or your organization, where you have multiple PCs that are interconnected using a LAN. So you are creating a your own private network, and you have connected multiple machines, and those multiple machines can share the folders, and anyone can transfer or put files in all different computers using the LAN connectivity. So it's a type of network, but it requires security because it has to be private. It should not be exposed to public internet. And there are multiple firewalls are also there that give proper access to proper user. Anyone from the outside your organization or from the internet cannot use that network, so that LAN network. So this is a small example of how we design a network. There are multiple topologies of network as well. We don't go in that direction because we have to look into the networking for GCP. So GCP is also providing a similar kind of networking ability, so we can connect multiple services and utilize it as per our requirement. So let's say we have 5 or 6 services. Let's say we have database, we have compute engine, and then we have some CDN service, then we have some S3 bucket. So all three are different services, and to work with all these services we must need a connectivity, or maybe we have an API gateway, we also need a connectivity for that as well. So we have to connect all these services with each other, and that is how we can run an application, run a proper whole architecture service and serve our customers. So this designing and this whole architecture is is created using networking in GCP. So it's like as definition says, a foundation for connecting your resources. So that's how we connect our resources, and that resources later used to serve the users. So networking is kind of is used inside Google Cloud, and if we are using something multi-cloud or connecting with on-premise, then also this networking feature and networking multiple networking aspects of GCP helps you to prepare and create a very robust and safe infrastructure. Okay, so let's see how this networking works. So first of all, we will cover two things, that is a VPC and a subnet. So what is a VPC? So VPC is all about you can say a network in which you can place your services, infrastructure items, and subnet is smaller parts of VPC, where you divide your VPC in different types of small network boxes, where you put your infrastructure separate with each other. So and you can then put firewall rules, any other infrastructure rules. So you can make one part of your VPC private, one part VPC public. So it gives you modularity, it gives you privacy, it gives you ability to make your infrastructure more secure. So subnets are smaller parts of VPC, and yeah, it's important to understand, like anything that is deployed in cloud is primarily deployed inside VPC, and then primarily deployed inside subnet. Nothing is deployed outside a subnet. Whenever you create a service, by default a default VPC is there, a default subnet is there with its valid CIDR range. So this UI example here, this example you see, there is a VPC network, and in that VPC network we have two subnets, US West, US East, and these two subnets are having two VMs. Okay, and these VMs are connected with each other using VPN gateway. So VPN gateway is a altogether a different concept of networking that we'll cover later, but I think you understand like what is subnet is. So when we break our VPC network in two different subnetworks with their own IP ranges that are not overlapping, then these two networks are known as subnets, and in these subnets we deploy our services. So this is a basic overview, like how these things works. Let's look to our some other aspect as well. We have IP addressing, we have firewall rules, we have cloud NAT, cloud VPN, interconnect and peering, service controls. So these are different aspects of networking. These are obviously important concepts, but from the exam point of view, not much important, but you have to have the understanding of these things. So IP addresses, as we all know, it's an address of your service, your infrastructure, where a user can connect or any infrastructure internally can connect. So it's important to have a IP address. IP address can be static, can be dynamic, and then we come across this firewall rules. So firewall rules are rules provided to the inbound traffic or outbound traffic. So it gives restriction, it gives control to you, like what comes in, what goes out. So these are firewall rules that also helps you to secure your infrastructure, you secure your services. cloud net is something, I would say, let's say you have a service that is running in a private subnet, and or itself it's a private IP, and let's say you have to connect with some outer infrastructure, outer service. So this cloud net will allow you to provide external access. I would not say external access, but it gives stability to your service, so it can connect with the internet. So that's important point. Then we have a cloud VPN. It's a virtual private network that allows you to connect with on-premise services or something outside the of the cloud. So it gives you a secure connection, and any of the services outside the Google Cloud, maybe inside the premises, can connect with the Google Cloud services. So that gives you a secure path for the connection. Interconnect and peering are different ways of connecting with the network of Google Cloud from the on-premises. There are different types of interconnect, dedicated interconnect. There are multiple types of peering as well. So these all are services of Google that allows you to connect with your on premises. Peering has its own two types, that is direct peering, carrier peering. So these are some services that you need to know, uh, that I already explained, like why this is used. Then we have service controls. So service control is all about providing a I would say a confined area, or I would say a specific security feature, and due to that, anything that is inside that perimeter will not be accessed or be sent outside that perimeter. It's something related to your geolocation. So let's say in Europe there is some health data, and if you define a parameter using the service control, then it's impossible to move that data from outside that Europe, outside Europe. So this is allowed, this allows anyone to make your data secure and safe. So I think these are some networking aspects I was thinking to discuss. This is very brief overview of all these networking aspects. Then there comes a load balancing. So we have already talked about how multi-zone and multi-region architecture allows you to give you very high availability. But having a high availability, it requires to be have something known as load balancing. So load balancing is a way to distribute your network or I would say request in such a way, like users will get quick, fast, and very reliable access to their resources. Okay, so obviously there are global or regional load balancers available that works in on different way, and there are multiple aspects of that we will cover in later videos, but this is how it's important. So load balancing depends upon the type of network it's coming. Maybe it is HTTP, maybe it's TCP, maybe it's UDP. It can be internal load balancing as well. Okay, and in this concept we also have SSL offloading as well, that is required to so it's a concept you understand like this, like internally, when some request comes, maybe it has HTTP request and SSL is there. So SSL offloading is required to so that internally when that request flows to the services of GCP, it doesn't have SSL in it, because it will add more latency. So just to remove the latency and makes things easy, SSL offloading is done. So easy and frequent movement of request can be done inside GCP networks. So that's also a different thing, but it's important to understand this. Okay, and obviously load balancing helps to balance traffic across multiple instances and services that we all know. Networking also helps in auto scaling and auto healing, because auto scaling and auto healing is required and it's important, but it happens only if you have proper networking between your services. So this is important. And then when networking is perfect, when you have a good architecture and everything is placed in proper in proper manner, then monitoring it and providing a security is also becomes very easy. So as I mentioned previously, the service controls, how it works. So it's obviously prevent data from being accessed from any other zones, regions. And then we have network intelligence center that allows you to monitor and visualize or detect any kind of uh, I would say issue or any kind of vulnerability. If you see, it can be identified using this network intelligence center. Then we have firewall insights that helps you to analyze the rules, because sometimes there are because rules, firewall rules are all about numbers, because if you not provide perfect or accurate firewall rules, what will happen, you think it's done perfectly, but it's in reality it's not. So this firewall insight feature allows you to analyze your already provided firewall rules, so you can test the effectiveness of it and improve it. So these services are available with us to improve, strengthen and make your networking more robust. Next, I think I also need to tell you like how organization hierarchy works in networking, because there must be some question related to hierarchy of organizations in GCP. So first of all, this organization type of hierarchy is only given to uh, some organizations related accounts, not a normal user account. So first of all, the higher hierarchy is organization. Then there is folders. In those folders you create folders of your multiple departments, maybe teams, maybe products. Then in those folders you create your own projects. So I will show how projects are created, but you understand like projects are always inside some folder and folders are always inside an organization. And once you created your projects, then that projects have resources in it. So this is how hierarchy work, and this is something very important to understand, because it's important to understand like when there are some IAM rules applied, it happens like it has been applied on organization level, then obviously these rules will drill down and come to cross to resources as well. So you, if you don't understand the hierarchy, you will not understand how things things are applied on the parent level of hierarchy, and how it is flows down to the child level of hierarchy. So I suggest you to remember this, and that's important for your upcoming uh, sessions of this video. So I think I have completed everything, and we are good to wrap up this video. Let's meet in next video. Till then, thanks, and thanks for joining this video. Please don't forget to share or like this video. It's motivate me to create more videos. I'm not a very professional person, but I'm trying to teach you what I know. So thanks everyone for joining this.